So last logarithmic equation we're going to look at is one that is just terrifying at first, but this one's all bark, no bite. There's nothing to this one that we haven't seen before. So just remember your general techniques. One thing that's nice to do is isolate your logarithms, so you just have one log on both sides. You may be looking at this and saying, well, I've got logs on both sides, and they're all the same logs. It's just natural log, right? Remember what this ln thing is? That's just log base e. So maybe you're looking at all these things and saying, well, they're all equal logarithms. Can't I just cross them all out, right? Can't you just come along this whole list and say by logarithmic equality these things all cancel out? Well, no, you can't. You can only do that when you have a single logarithm on each side. So let's try to rewrite this as single logarithms. Using the quotient rule. Remember, this is the quotient rule of logarithms that allows me to rewrite these. I'm going to rewrite the left side as natural log of the x plus 12 goes on top. And since the next log, this negative sign tells me that goes on bottom, so that's going to be x plus 4 on bottom. And that equals, by the same quotient rule, natural log of x plus 9 on top. And the negative sign over here sends that x plus 3 to the bottom of the fraction. Now you have equal logarithms. So you can come along and cross those logs out by exponential equality. And let's see what that gives us. We get x plus 12 over x plus 4 equals x plus 9 over x plus 3, right? No sweat. It's just a rational equation. So however you choose to solve this, I would probably use cross multiplying. Okay, so the way you can think of cross multiplying is we're sending that denominator from the right bottom to the top left, and the denominator from the bottom left to the top right. Another way you can think about this, if you never learned cross multiplying, is just this. I'm going to multiply each side by x plus 3. The purpose being, I want to cancel out that denominator. I'm also going to multiply each side by x plus 4. Purpose of that being, I want to cancel out this denominator. Okay, it has the same effect in the end as cross multiplying. So what we get is x plus 3 times x plus 12 equals x plus 9 times x plus 4. Okay, so just a pleasant little bit of foiling, and we should be done with this. We get x squared plus 15x plus 36 on the left. On the right, we get x squared plus 13x plus 36. Oh, did I do that right? 36. Yep, okay. So we get all this stuff, and then I'm going to just try to bring everything over to one side. So we're going to do minus x squared, we're going to do minus 13x, we're going to do minus 36 from each side. Minus x squared minus 13x minus 36. So you see those x squareds cancel out. The 36s actually cancel out. This is a weird one. All you get left on this side is 2x, and there's nothing left on the other side, so you get 2x equals 0. Well, that kind of went fast. Now you get x equals 0. Funny solution. Let's just check if it works. Remember what I want to check. I want to make sure that when I substitute x equals 0 into the original equation, I get no negative arguments. Negative arguments in a logarithm, break it. And you can see, if you look at each one of these things, they're all x plus something. So whether that's 0 plus 12, 0 plus 4, 0 plus 9, 0 plus 3, it's all positive arguments. So this x equals 0 looks pretty good. And you could actually plug this in and see if it's exactly equal. That's a little more rigorous. I just want to do a basic sanity check and say, this is good because I have positive arguments. Okay, and we'll call it that. If you're curious, you can always go back and double check this.